Combination of transformations. The following transformation shows how the dilation from the y-axis, when it's performed after the translation, only affects the coefficient of x. For example, for the function y equals x cubed, when we need to translate 2 units in the positive direction of the x-axis and 3 units in the positive direction of the y-axis, we need to subtract 2 from x and add 3. When we need to dilate by factor 3 from the y-axis, we need to multiply x with a third. And when we need to reflect in the x-axis, we need to change the sign of the whole function. The following transformation shows when the translation is done after the dilation from the y-axis, then the dilation becomes a common factor. For example, for the function y equals x to the power of 5, when we need to reflect in the y-axis, we need to change the sign of the x value, and since the power of 5 is odd, then the whole function becomes negative. If we need to dilate by factor 2 from the y-axis, then we need to multiply by a half the value of x, and we can raise it all to the power of 5 and can become negative x to the power of 5 over 32. Finally, when we need to translate by 2 units to the positive direction of the x-axis and 3 units in the positive direction of the y-axis, we need to subtract 2 from x and add 3 to the whole function. The following example shows how we can describe the series of the transformations. So for the function f of x equals 4 minus 2 square root of 2x plus 6, the first transformation that we done is dilate by factor 2 from the x-axis, then dilate by factor a half from the y-axis, then reflect from the x-axis, translate 3 units in the positive direction of the x-axis, and translate 4 units in the positive direction of the y-axis.